Hello and welcome to a short tutorial on how to find the probability of two events. Now we start with a question that involves two dice being thrown and we're going to add up the total of the outcomes on each dice, okay, the total score. So we've got different things, different probabilities to work out. First of all, the probability that we get a total of 9, that we get a total that's an odd number, that we get a total that's greater than 10, or a total that's less than 8. So I wouldn't recommend doing this question without drawing yourself out a sample space diagram. And what we say here is that we're going to do the total score. So we're going to be adding them up. Whatever we get on this dice, we're going to be adding on to what we get on this dice. So let's start to do that and fill in this table. Okay, so 2 plus 1, 3, 2 plus 2 is 4. And this is really quick in this instance because, 3, 3, 4, 5, 6, 7. It's just consecutive numbers, isn't it? So it's really methodical, really nice and easy. 7, 8, 9, 10. 7, 8, 9, 10, 11. Then we've got 12 down here. We could even go backwards. There we go. Okay. All right. So the first thing that we've got then, part A, find the probability of getting an answer of 9. How many 9s have we got? Let's count them up. 1, 2, 3, 4. And what's it going to be out of? Well, how many outcomes did I have here? Had 6, so its length is 6. How many outcomes did I have here? 6 again, 6, the numbers 1 to 6 on a dice, that's its width. 6 times 6, I've got 36 cells there. So 36. And what's the highest common factor of 4 and 36? It's 4, isn't it? So how many 4s in 4? 1. How many 4s in 36? 9. There we go, 1/9. Right, simplify it down, right down to its lowest terms. Part B, we're looking for the probability that the total score is an odd number now. So how many odd numbers do we have? Well, we've got 3, 5, 7, and 9, and 11. Okay, so we're going to count those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the probability of an odd number is 18 out of 36, which is actually how many 18s go into 36? 2. It's a half, isn't it? And that would make sense because half the numbers are odd, half the numbers are even. Odd and even numbers are alternate, so we've got an even number of cells there, so that would make sense there. C, probability that we're greater than 10. Okay, so how many numbers we're going to ask ourselves are greater than 10? That's really nice and easy and quick to see, isn't it? We've got 11s and 12s. So we've got 3 of them, 3 out of 36. And we're looking at the 3 times table there, aren't we? It's the highest times table that has both of those numbers in, or otherwise we can think, what's the highest common factor of 3 and 36? So how many 3s in 3? That's the highest common factor. We can divide 3 by 3. We've got 1, and we've got 12. Okay? And last but not least, the probability less than 8. Last one. How many of the numbers are less than 8? Well, it's the numbers from 2 to 7, isn't it, here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, I think. I'm going to double check. 10, 15, yes, 21 out of 36. Highest common factor is the next question. Can I divide through by a highest common factor? I think the highest common factor there must be 3. So 21 divided by 3 is 7, and 36 divided by 3 is 12. That's the best answer there. It's the simplest answer to that question. Okay? All right, excellent. That's the first question done. Hope that was okay. Example 2. When 2 unbiased coins are tossed, determine the probability of obtaining 2 heads, 2 tails, a head and a tail. First question, unbiased. If we've got a biased coin, that means that it's weighted on one side. So it's not actually a fair coin. If it's unbiased, that's a much fancier way of saying it's a fair coin. Okay? So 2 coins this time. Last time it was dice and we had 6 outcomes. When we have coins, how many outcomes have we got? Well, we've only got heads and tails. Okay, and then for coin 2, I'm going to do a really rough diagram here. We've got heads and tails. Okay, and in here, I'm going to draw my grid, and I'm going to see what the possible outcomes could be. So head on coin 1, head on coin 2, head, head. Head on coin 2 and a tail on coin 1. We could have head, tail. A coin 2 giving us a tail, and coin 1 giving us a head, tail, head. And tails on both, tail, tail. So the ones in green, these are our possible outcomes in this scenario. Okay. And so there's 4 of them all together. Like last time was 6 by 6. This is 2 by 2. There's 4 possible outcomes. And part A, the probability of 2 heads. Well, how many of them have 2 heads? These 3 all have a tail in them. This is the only one that has 2 heads. So it's a 1 in 4 chance of that. We could have 25% or 0.25 as well, up to you. All good. Okay, 2 tails. Well, there's 1 of those as well. Probability of 2 tails is 1 in 4. And C, a head and a tail. Well, there's 2 actually. Okay, so a head and a tail. There's 2 of those out of 4. Doesn't matter what order they're in, which is 1/2 when simplified. Okay, so nice and easy. As you can see again, once we draw the sample space diagram, life is really easy. Third example. Now this one is a little less orthodox in that it's not just a dice, it's a fair dice or a coin. We've got some quite specialized looking spinners here with different outcomes on them. 2 spinners which are both spun. What's the probability that the total score on the 2 spinners is 7, 6, greater than 10, less than 5? Well, I'm going to draw myself a sample space diagram just because I wouldn't try and do it without one. Okay, so we're going to have, so what are the outcomes on spinner 1? Let's call this spinner 1. Spinner, excuse the handwriting, spinner 1. It's terrible. Spinner 2. Okay, so we've got 1, we've got 4. Oh, why am I not doing that on order? Let's actually, we can do better than that. 1, 2, 3, 4. On the second one, it's 1, 3, 5, 7. 1, 3, 5, 7. Okay, this is not the neatest of diagrams, but I'm sure you're okay. I think you're okay. Right, so let's put the lines in. And let's just double check the question. The total score, yes, so we're going to be adding them again. Okay, total score. So let's add. 1 plus 1 is 2, 2 plus 1 is 3, 4 and 5. We've got 4, 5, 6 and 7. We've got 6, 7, 8 and 9. We've got 8, 9, 10 and 11. So they're all our possible outcomes. And how many of them are there? Well, it's 4 here, 4 outcomes here, 4 outcomes here. There's 16 of them. It's a 4 by 4 grid inside here. Okay. In fact, I might just put that in a separate color just to make sure that the actual outcomes are standing out against the numbers on the spinners. Okay, so it's a 4 by 4 grid. They're all our possible outcomes. Now we can answer the question. So part A, what's the probability of getting a 7? How many 7s have we got? Well, they're not in such a methodical sort of order there, are they? So we've just got to try and spot them. 1, 2. I can see 2 out of the 16. Can simplify that, of course, to 1/8. B, probability of a 6. 1, 2, again, yep. 2/16 is 1/8. C, greater than 10. So anything greater than 10, well, I can only see an 11 actually. So greater than 10, that'll be 1/16. There's quite a low chance of getting anything that's greater than 10, 1 in 16. And finally, less than 5. Less than 5. How many numbers less than 5? 1, 2, 3, 4. Okay, it's only the numbers up to 4, isn't it? Because they're all less than 5. Once we get to 5, we are 5. So 1, 2, 3, 4. 4/16. Well, that's nice because I can simplify that. The highest common factor is 4, so that would be 1/4. or 25%, 0.25. Okay, so again, a nice example of how once we draw a sample space diagram, that is the key to answering these questions. Never try and do it without. Okay, I hope that's been really nice and clear, and that this topic is how you have gained much confidence with this topic now. Okay, good luck.